Hello everyone, in this video I will discuss about classification of ligands. Okay, now this is classification of ligands. Classification of ligands. Okay, so classification of ligands. So first of all you have to know that denticity. What is denticity? Okay, denticity. This is very important, and this one is you have to know for this is first basic foundation. Okay, this denticity. So define denticity. Classification based on denticity of ligands. So denticity is nothing but this one is what? The number of coordinating or ligating. So this one is the number of coordinating okay, coordinating or ligating atoms present in a ligand. In a ligand is called the denticity of that ligand is called the denticity of that ligand. Okay, denticity is very easy. The number of coordinating or ligating atoms present in a ligand is called the denticity of that ligand. So the denticity is how many types? So many types is there. So one is monodentate ligands, another is bidentate ligands. Monodentate ligand is there, monodentate, bidentate, tridentate, tetradentate, like this, tetradentate, then pentadentate, then hexadentate. Okay, so first of all types of ligand. First types, this is monodentate or unidentate. See, monodentate or unidentate, dentate, D-E-N-T-A-T-E. Okay, monodentate or unidentate. So monodentate, nature of ligands. Monodentate, this is nature of ligands. There are three natures. One is anionic ligands, another neutral and cationic. So monodentate is how many types? Or this is nature only. Monodentate nature is there are three natures. One is anionic ligands, cationic ligands, and another one is neutral ligands. So monodentate is nature of ligands of monodentate. So nature of ligands of monodentate is three. First is anionic ligands, second one is cationic ligands, third is neutral ligands. So anionic ligands, some examples of anionic ligands. So some examples of anionic ligands is say F minus, Cl minus, Br minus, then Cn minus, OH minus, okay, OH minus, then SCN minus, NO2 minus. These are anionic ligands. This is anionic sign, okay, negative sign. So this one is anionic ligands. And neutral ligands, see neutral. Some neutral ligands example. Some neutral ligand example is amine, water, carbonyl, NO, nitrosyl, NO. This one is nitrosyl. Pyridine C5H5N. This is pyridine, amine, water, carbonyl, nitrosyl. Another one is phosphine. So these are neutral ligands. Okay, so these are neutral ligands. Now cationic ligands. So cationic ligands, some examples: NO plus, H2N bond NH3 plus, NO2 plus. Okay, so these are cationic ligands. So nature of ligands of monoentate, there are three nature. First is anionic, this is examples. Neutral, these are examples. Cationic ligands, these are examples. Okay, after that bidentate. Okay, now bidentate. So bidentate or didentate ligands. Bidentate, dentate or didentate ligands. Bidentate or didentate ligand means donor site, two donor sites are present, two donor sites. Bidentate or didentate, this is two donor sites are present. So first is ligands with one neutral donor. Ligands with one neutral donor. So ligands with one neutral donor and one acidic donor and one acidic donor. Okay, say one example, gly. Okay, gly means glycineto. Glycineto. So what is the example, or no, write the example then. Glycineto, you can write here CH2 bond C double bond O, here minus, here NH2. Okay, this is one donor site and this one is another donor site. So two donor sites, that's why this one is bidentate ligand. This is glycineto. Another one, En. This En is what? En is neutral ligand. This is acidic. Now this part-1. See, ligands with one neutral donor. This is neutral part. Okay, one acidic. This one is acidic part. And ligands with two neutral donors. So two neutral donors. Then example En. This En. So what is the full form of En? Ethylenediamine. Ethylenediamine. Okay, now this example, this one is ethylenediamine and structure is CH2 NH2, here NH2, this one and this one. So donor side, here two donor side, this one and this one is donor side. Okay, another one is PN. This PN name is propylene diamine. Propylene diamine. Now what is the structure, or draw the structure? Structure is CH. Very important, this structure is very important because that chelating. Okay, now when chelate formation, that this structure needed. Okay, so you can learn this structure. You have to practice 3-4 times to write. Okay, then NH2, here also NH2. So donor side, this one also, here one donor side, this one also one donor side. This is neutral. Okay, this one is neutral. Another one is bipi. This one also neutral donor. or neutral ligand. Okay, bi-pi means bipyridine. Bipyridine. Bi-pi is bipyridine. So structure is like this. One pyridine structure here. So another pyridine structure, this one. So this one is bi-pi. Donor side, here two donor side. Okay, this one is two donor side. Understood? This one. Another one is, this one is a two acidic donor. That means two acidic donor. So two acidic donor is oxalate 2. Two acidic donor is oxalate 2. OX2 minus. So this one's name is oxalate 2. Oxalate 2. So structure C double bond O bond C double bond O bonds minus this one. Two donor sides. This one is one donor side and this one is another. This is acidic donor because negative sign. Okay, and here this is neutral donor because here no sign, only this one's lone pair is there. Okay, lone pair. The two lone pairs, here one lone pair and here one lone pair. There are two lone pairs. Okay, so monodentate and bidentate, these are finished. So many examples is there. Okay, you can follow that book also. That e-book we will very important and in next video I will discuss that tridentate ligand, dentate ligand, pentadentate ligand, and last one is hexadentate ligand. Okay, and please subscribe my channel for upcoming videos. This is very important. Okay? And thank you.